Hi everyone, I would like to talk about the two-sum problem as my intro to algorithms series. It's a very classic problem that gets asked in many interviews. I was asked about this problem in a recent interview, so I would like to talk about 4 different ways to solve this problem. Feel free to comment below to let me know what problems you're interested in me covering. The problem statement is that given an array of ints, return a pair of ints that sums up to a target. There are 2 assumptions that we make here. 1, the array is not sorted, and 2, only one solution exists. We can walk through one example. Given an array of 4, 6, 7, -2, 8, we want to find a pair of ints that sums up to a target of 2. At first glance, if we do this in our head, the pair of ints that we're looking for is 4, -2, because 4 plus -2 is equal to 2. The first way I would like to talk about how to solve this problem is by brute force. It's a good habit to have in an interview to start off with the brute force solution. So in the brute force method, we want to find basically looking at every single pair of integers that we can find, and to find to iterate through every single pair of integer only once. We set 2 pointers, basically the first pointer pointing to the very first element, and the second pointer will go through the rest of the array to basically pair up the rest of the array with the first element. And after we've done that, we move our first pointer to the second element. Then our second pointer will go through the rest of the array after the second element to pair up the rest of the array with the second element. So to run through this as an example, at first we have our first pointer pointing to 4 and our second pointer pointing to the index after 4. In this case it's 6. So our first pair is 4, 6, and then we move our second pointer and our second pair will be 4, 7. Then we move our second pointer again, and our third pair will be 4, -2. And we move our second pointer again, and our next pair will be 4, 8. So after we're done with the second pointer, we move our first pointer over, and our second pointer again will be one element after the first pointer. So our next pair will be 6, 7, and we move our second pointer, and our next element, next pair will be 4, -2. We move our second pointer again. Our next element is 6, 8, and we move our first pointer after we're done with the second pointer, and our second pointer will still be one element after the first pointer. So our next pair is 7, -2. Then we move our second pointer again. Our next pair will be 7, 8. After we're done with the second pointer, we move our first pointer to the next element, and our second pointer will be initialized to the element after the first pointer. So our pair will be -2, 8. Finally, we move our first pointer to the very last element of the array. Our second pointer will be outside the bound of the array, and so we can't make any more pairs, so we're done. And while making these pairs, we can also check for their sum. So in this case, the sum is 10, and then it's not our target. in this case our sum is 11. It's also not our target. In this case our sum is 2, and it is our target. We can terminate here, or we can check for the rest of the pairs, which is unnecessary in this case because our assumption is that only one solution exists. So I have a sample program written to show you guys how to code this up. This is a C++ program. So the way we iterate through our pairs of integers, like we did by hand, we start off with our with the integers that starts with index 0, which is 4 in our case, and then we pair 4 up with rest of the array. So the second index will start at 1, so that's 0 plus 1, and then iterate through 0 plus 1 to 0 plus 2, 0 plus 3, 0 plus 4. So in our case, to generalize this, we have the first element in the pair start at I equal to 0, then the second element in the pair will start at I plus 1, and we increment this second pair until we reach the very end of the array. And let's see what the main program does. So the main program will print out the array that we're trying to find the two sums for, and then we'll calculate the two sum based on this array and target, and then we'll print out our answer to the two sum problem. So we have a sample output, and these are the pairs that we generated from this array, and compare this to what we did by hand. They're identical. And in our two-sum function, when we're iterating through the different pairs, when the pairs add up to target, we push that pair into our result array or vector. The second method I would like to talk about is the binary search method. For this method, we need our array to be sorted, and sorting will take us O of n log n times. After sorting, we can fix one element. In this case, our first element is -2, and then we search in the rest of the array, which is also sorted, using a binary search, looking for the difference, which is target minus element we fixed. So in this case, our difference is 2 minus -2 is equal to 4. So what this means is after we fix at element -2, we search in the rest of the array, which is also sorted, using a binary search for 4. And we do this for every element. So we do this, for example, we do this for 4, and then we search for in the rest of the array after 4, using binary search for the difference between target and 4. And we'll fix element 6 and search in the rest of the array. Then we will fix element 7 and we search in the rest of the array. Here is the sample code of what this algorithm will look like. So we'll first sort the input array, and that will take up O of n log n time. Then we fix one element at a time. We'll be fixing from element 0 to the element right before the last element. Then we will begin to binary search in the rest of the array for the difference. And here we just have a very standard binary search algorithm where the rest of the array is defined by i+1 to the last element of the array. And this whole for loop will take up O of n log n time. This is because search in the rest of the array will take up O of log n times, and we will do this about n times. And we will run this program, and hopefully we'll get the right results. So here we have the original array. Then we have the sorted version of the original array. Then we'll have all the indices that we went through, all the pairs that we went through using this binary search method. And our final result is -2, 4, which is the correct result that we want. The third way to do this would be by using a two-pointer method. This method we will require a sorted array. So given our original array, we will sort it in O of n log n time. Then we will initialize our 2 pointers, one at the beginning of the array, one at the very end of the array. So given that the 2 pointers is pointing to -2 and 8, we will calculate its sum, which is 6. And given that 6 is greater than our target of 2, that means we need to decrement the higher pointer down, decrement the higher pointer. This is because we're looking for a pair that's equal to 2 and 6. There's the sum of -2 and the maximum number, the max in the array is greater than the target of 2. That means we need to try a number that's less than the max to pair up with 2 to see if we can get a closer to the target or equal to target. So now after we've decremented the high pointer, we will have -2 plus 7 is equal to 5. 5 is still greater than target of 2, so we will decrement the high pointer again. Then we will have -2 plus 6 is equal to 4. 4 is greater than 2. We decrement the high pointer again. Then we will have -2 plus 4 is equal to 2. And 2 is equal to the target. So we're done searching. This search method with a 2-pointer will give us O of n time. This is because we will only end up looking at the whole array once. Let's try another example where we have to increment the low pointer. So given the original array and after we sort it, and that target is equal to 10, we will initialize our low and high pointer at the two ends of the array. So in this case, the sum of the 2 pointers is -2 plus 8 is equal to 6. And 6 is less than 10. So this means that we have to increment the low pointer. After incrementing the low pointer, our sum of the 2 pointers is 12, and 12 is greater than 10. That means we have to decrement the high pointer. After decrementing the high pointer, we have 4 plus 7 is equal to 11. 11 is greater than 10. We decrement the high pointer again. Now the high pointer is pointing to 6. And we have 4 plus 6 is equal to 10. 10 is equal to 10. So we found the 2 pairs that will add up to our target. Here we see the example of how to do the 2-pointer method with code. So first we sort the input array. This will take us of n log n time. Then we print the sorted array just for reference. Then we want to initialize our low pointer and our high pointer. Our low pointer will point to the 0th index. Our high pointer will point to the last element of the array. So we go through the whole array while the low pointer is less than the high pointer, because when they point to the same element, that's only one element basically. So our sum would be the sum of the element that the low pointer is pointing to and our high pointer is pointing to. So if the sum is equal to target, then we return the pair as our answer. If our sum is greater than target, that means we need to lower our sum, so we need to make sure our high pointer gets decremented. If our sum is less than target, which is this last case here, we know that our sum needs to be higher, so we increment our low pointer. If we can't find an answer, we return an empty pair. The final method that I want to talk about is by using a hash map. The goal of using a hash map is to only see the elements once. So since we want to find a pair of elements, we can initialize our hash map, which we can call scene to 4, which is the first element. So then we start looking at the second element, which is 6, and our hash map is still 4 at the moment. So if we look at 6, we want to ask ourselves what pairs up with the number 6 to get our target of 2. So we want to find the difference, which is target minus element, and in our case it will be 2 minus 6 is equal to -4. So we know that -4 pairs up with 6 to get our target. So we want to basically search in our hash map if we have the number -4 to pair up with 6. So in this case we don't. So we add the number 6 into our hash map, and then we move on to the next element in this array, which is 7. So for 7, we need -5 to pair up with 7 to get our target of 2. Then we look in the array, our hash map, if we have -5. In this case we don't, so we add 7 into our hash map, and we move on to the next element. Our next element is -2. With -2, we need the number 4 to pair up with -2 to get our target of 2. In this case, we do have 4 in our hash map, so we're done, and we can output -2 and 4. Let's see the implementation of this in code. So first, we initialize a set, because in our case, our hash map can just be simplified into a set, where a set stores the integers that we've seen only once. So if we have a repeated integer, because we only need one pair as our answer, we only need to store that specific integer that we've seen once. So we initialize it with the first element that we see, and then starting from the second element, we can basically go through our algorithm where we find the difference as target minus the element that we're currently focusing on. And then we try to find the difference in our set. If we're able to find that difference, then we have the pair as our answer and we can return it. Or else we have to record that we have seen a certain element, basically the element that we're focusing on. Then if all else fails, we have to return an empty pair. In summary, this is the 4 different methods that we've talked about today on how to solve the 2-sum problem. So the first method is the brute force, where we went through every single pair of a pair of elements in the array. So this will take up O of n squared time with space complexity of O of 1. If we don't count the input array, the space complexity of the input array. And then we looked at binary search, where we have to sort the array first, because we're assuming that the array is unsorted in the beginning, and this will take n log n time for sorting. And we fix one element, and then we search in the rest of the array for a pair that can pair up with that element to get our target value. In that case, the search itself in the rest of the array, will take up log n time, and we do this about n times. The space complexity is still of 1. The third method is the 2-pointer method, where we have to sort the array first, and that took us O of n log n time. And then with the 2 pointers, after the array is sorted, actually only take us O of n time. But the whole process will take us O of n log n time, because we're taking the greater of the 2 big O's. So because O of n log n is greater than O of n, so our total time complexity is O of n log n, and our space complexity is O of 1. Finally, we went through the Hashmap method, where the time complexity is O of n, but we need another O of n space to store the hash map, so that's where our space complexity comes from. Thank you for watching, and feel free to let me know if there's any questions in the comments.